All right, first I'm just recopying the equation. All right, so in order to find the center and radius of this circle, we need to put it in standard form. It's currently in general form. Notice that when we notice that we could divide this equation by a 4. All of the terms of this equation have a common factor of 4. So if we go ahead and divide across the board by 4, we'll have x squared plus y squared minus 8x plus 4y minus 5 equals 0. Actually, when we complete the square, the coefficients of the x squared and the y squared need to be 1s, which we now have. So we divided the equation by a 4. The problem that'll be on the actual test will already have the coefficients of the x squared and the y squared terms with the 1. All right, so we divided by 4, and we want to get this equation in standard form. Recall that standard form is x minus h squared plus y minus k squared equals r squared. So the first thing we do is put the x terms next to each other, the y terms next to each other, and we move the negative 5 to the right. All right, now we have to complete the square. All right, so we have to add a specific number for the x's and the y's. We're gonna have x squared minus 8x plus and so it's right here we have to figure out what number do we add on to the x's. And to figure out what number goes right here, what we do is we take half of this number, the 8, and we square the result. So half of 8 is 4, and 4 squared is 16. Right, so 16 goes right here. And then we have plus y squared plus 4y, and we have to figure out, once again, what number should go on for the y's. So what we do is we take half of the 4 and square that. Half of 4 is 2, and 2 squared is 4. So 4 gets added on here. And on the right side, of course, we have the 5. And whatever numbers I added to the left, the 16 and the 4, I have to add those to the right side as well. Right, so that process of adding on the 16 and 4 in order to make a perfect square trinomial is called completing the square. So these two trinomials that I just outlined are now perfect square trinomials. What that means is they factor into two of the same types of binomials. So what numbers multiply to 16 and add to negative 8? That would be x minus 4 and x minus 4, which, we could write that as x minus 4 squared. And then for the y's, what numbers multiply to 4 and add to 4? That's y plus 2, y plus 2. But we could just write that as y plus 2 squared. And 5 plus 16 plus 4 adds up to 25. And we now have standard form. This equation right here is the standard form, and I can now identify the center and the radius. The center of the circle is located at positive 4, negative 2. Notice that we changed the signs of the numbers in the parentheses. And the radius squared is 25. And so we square root both sides and we get 5. All right, so now we just completed part A. We found the center and radius. They want me to graph this circle. So to graph this circle, I'm going to draw a coordinate plane. And first we got to plot the center. The center is located at 4, negative 2. Actually, I'm concerned that I didn't make my coordinate plane maybe big enough. When you graph this in my math lab, you can just use the graphing tool, but I should have made more room on the right. But let's see. So There's 5, 6, 7, 8, 9. That's 10 right there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. That's negative 10. Alright, so the center is located at 4, negative 2. 4, negative 2 is about right there. There's the center. Now what we do is take the radius. The radius is 5, so we're going to go up 5 from the center. So if I go up 5, it'd be, let's see, it'd be 1, 2, 3, 4. Looks like it'd be about right there. If I go up 5 from the center, that point would be 4, 3. And then if I go down 5, let's see, it'd be down here at negative 7. Right, the center's at 4, negative 2. So if I drop down 5, that would be at 4, negative 7. If I go to the right 5, it'd be over here at an x coordinate of 9, because the center has an x coordinate of 4. So that's 9, negative 2. And if I go to the left 5, it'd be over here at an x coordinate of negative 1. So that point would be negative 1, negative 2. And now you just graph the circle as best as we can by hand. Again, in my math lab, we would use the circle tool. That completes part B. Part C wants me to find the intercepts. To find the intercepts, we have to put zeros in for the variables. I'm going to go to the next slide for the intercepts. Alright, so the equation is 4x squared plus 4y squared minus 32x plus 16y minus 20 equals 0. Again, if we go ahead and divide by 4, it would simplify the equation, so let's do that. Okay, to find the x-intercepts, we're going to put 0 in for y. If I put 0 in for y, we'll have x squared minus 8x minus 5 equals 0. Yeah, let me just make sure I divide it by 4. Right, yep. Alright, this equation doesn't factor. There are no numbers that multiply to negative 5 but add to negative 8. So to solve this, we're going to use the quadratic formula, which I'll write over here. Just as a reminder, this is the quadratic formula. Alright, so x equals negative b, so that's negative 8, plus minus square root b squared minus 4ac over 2a. And so we have x equals 8 plus minus square root 64 plus 20 over 2. 8 plus or minus the square root of 84. 84 is not a perfect square, but I think we can simplify it, right? 84, here I'll do this, let's do this over here on the side. Square root of 84 is the same thing as square root of 4 times 21, and I can square root the 4 to 2. So we have 8 plus or minus 2 square root 21 over 2, and I can reduce this to 4 plus or minus the square root of 21. And there we have the x-intercepts. 4 plus square root 21, 4 minus square root 21. Now again, recall on the test, I won't be asking you to find the intercepts for this circle, as there'll be other questions earlier from the earlier sections where you'll have to find the intercepts. So we just found the x-intercepts. To find the y-intercepts, we'll put 0 in for y. So I'm going to go back and put 0 into y to this equation. Doing so gives me x squared minus, oops, I'm I apologize. We just did y equals 0, didn't we? Yeah, we just did y equals 0. I should be doing x equals 0 now. We're finding a y-intercept, so I want to plug x. I want to plug 0 in for x. And so doing that gives me y squared plus 4y equals 0. If I put 0 in for x, I have y squared plus 4y, and I failed to write the minus 5. Right, so putting 0 in for x to get the y-intercepts, we have y squared plus 4y minus 5 equals 0. This looks like it does factor. This factors to y plus 5 times y minus 1, and so we have negative 5 and 1. So no quadratic formula was needed on that one.